Okay, everyone. Welcome once again to this session that we'll be having data sufficiency. This is one topic which it poses a challenge to many students, but once you figure it out, it's one of the topics which can really help you get some marks, some good grades in the GMAT exam, and at the same time also save you time. Can really save quite some time using these data sufficiency kind of questions if you master it. So I would recommend that every person to try as much as possible to master it, um, so that they can be able to get an edge in the quant section of the exam. Not actually nowadays it's in the data insight section of the exam. So it really help you get an edge and also boost your scores. And it just requires to you to know what needs to be done and apply it. So before actually I go further, just to say that the data sufficiency questions, it's challenging because it's more or less unique to the GMAT exam. I don't know of any other kind of mathematical exam that has data sufficiency as a type of question that are being asked in an exam. It's only the GMAT exam that I know of it. So it's more or less quite unique to it. And you will be seeing it for the first time if you're coming to the GMAT exam. You may not have seen it before. Other topics like problem solving and probably algebra and other topics, you may have seen them before, and that's what we've been doing most of our lives in our academic lives and also progress. But data sufficiency, this forms more or less the very first time we get to encounter it. So just to as we proceed now to just the next one. So the material we do recommend for this that is normally comprehensive enough is from the Veritas Prep. It's quite detailed, and that's the material I used. That's the one we recommended to people, and that's what I've found to be quite good. Others also are actually the Princeton Review and other material out there that we normally do recommend to use. But this guide has proved to be one of the best so far, most comprehensive, and can be used to help you be able to ace the GMAT exam if you need to. So that's one thing. So for you to be able to tackle these kinds of questions, you need to be very conversant with the topics being tested. That's the first thing. You cannot just approach it as let's say a problem solving question and just go ahead and be able to try out numbers and find it, and I'll probably plug in and see if it works or not. Like you can like you may do in problem solving, but in this one it requires you to know the concepts, know the topics being tested, are the concepts of the questions being tested. And this is because that is where the trick is. That is where you more or less going to focus more in getting your answers. Yeah. So if actually the question is on number properties, you should know the concepts in that topic very, very well. Yeah. And I believe in the trainings you've also been actually been exposed to the narrative of being able to know your concepts very well, and then now you work on the approach. So the next thing is actually the approach. How do you approach data sufficiency questions? Yeah. See, normally there are three main steps in this. Three main steps. And the three main steps is first you analyze the question stem being asked. That's once we learn the question stem, then next you analyze the statements. And then once we analyze the statements, then now you can go ahead to do what? Apply the decision tree to get the correct answer. So each and every part of them as well, also like if you analyze the question stem, what does it entail? You simplify the question stem to the simplest term possible to make sense of it. That's what you need to do. So you could note this down, and actually these steps, note them down, apply them each and every question you do for the next 2 to 3 days, or over the next 2 weeks. Apply them to each question you do until it sticks and becomes part of you. That's one thing which you need to do. Yeah. So you simplify the question stem. Once you've simplified the question stem, then you consider all possibilities. These possibilities will be based on the concepts you know. Because if you don't know the concepts, you won't know all the possibilities. For instance, if it's actually it's let's say it's a number greater than zero, let's say x is greater than zero. It could be 0.01, could be 1, all the way to infinity. See. Now, from this one as well, also, if it's 0.01 to 1, that's actually a fractional decimal point. That's one thing you need to know. So if it's a decimal point, that's a possibility. Is it like a whole number, an integer, like from 1 all the way to infinity? And does it fall under the groups of of actually other numbers that could be under the whole numbers. Yeah, which numbers would they be? Which would be more or less like the real numbers? Which subgroups of the real numbers would they be? Is it a square? Is it a square root of a number? Is it like a prime number? Is it what kind of number is it? Is it an even number? Is it an odd number? You need to know those and all the possibilities that may come with it. You need to actually be able to consider all that. Once you've done that, then now actually you'll be able to know what do I need to have to be able to get if a question is if a statement is sufficient or not. So you need to know that given this information, the question stem, I've been told A and B, but I need to know C, which is now not known, to be able to get what is D. So this C, this is what will be sufficient. So that is it. So if you find a statement giving you only about A and only giving about D, but doesn't tell about this C part, then that will be insufficient because this is what you need to know. If from the statement you're given, you can't be able to solve for C, then it's not sufficient. But if you're able to actually if you're able to get the combination of information that you're able to address this C which has not been given, then yes, it will be sufficient. So the moment you know these ones and apply them, then actually you can now go inspecting the statements to see which one meets this criteria. Are you getting me? So once you have that, then now you can be able to know, okay, well, at that point, you're able to know what you need to know from each statement to know sufficiency. Then on next, you can now go to analyzing the statements. So the statements normally, as they are, as you can probably see, let's see, no, normally have them, I haven't put them here, but normally have A, which basically is just one is sufficient, and then B, which is normally two is sufficient. Yeah, but A is sufficient, but B is not sufficient. One is sufficient, but two is not sufficient. And then C, one and two together are sufficient, but independently they're not. And then B is one and two are sufficient independently. Sufficient independently. So which means both one on its own is sufficient, two on its own is sufficient. And then E, which normally is that neither of them is sufficient, even if you combine them is sufficient to the current knowledge. So none is sufficient. So the reason why they are this way, and actually they're this way, is because there's normally a step-by-step scheme for you to be able to get these answers. You can't just go and pick C or D or E without following a systematic approach to each choice. Yeah, as it happens in the problem-solving questions, which you may actually be able to just get your answer and you go to choice D and together D is the answer. That's it. No. You first of all have to assess each statement independently. Then actually find that one is sufficient. It is sufficient. Yeah. If one is sufficient, you have to still assess two and find that two is also sufficient or not. If one is sufficient, then you close out C and you close out E. So you're left with A, B, and D. If two is sufficient, and also if one is to be sufficient, then you close off A and B and left with D as the answer, which shows that each of them independently is sufficient. You get? That is now I go about it. If at all you find that one is sufficient but two is not sufficient, then you stop at that. The answer becomes A. If you find that two is sufficient but one is not sufficient, then you go to B. Actually, B becomes the answer. If both of them are not sufficient, then you combine them together to see if they're sufficient. If combining them creates sufficiency, then C is your answer. But even after combining them, you find that still they're not sufficient, then E becomes the answer. So you need to know all those steps and need to have them ingrained in you. It will get to the point where you do it so many times that you'll get to not even have to look at the multiple choices. Because you'll see the questions you have, you don't have the multiple choices because it's assumed that you know them. And if you don't know them, you can still refer to them and they'll be the same to each and every question. The whole question is which one will it be? C. That's not it. So that's the decision tree. That is how you go approach it. You start from A and B. You can start from either of them, either A or B, but you have to sort out A and B first before you go to D, C or E. Get D as in dog, then C or E. You have to follow that approach. You get me? Any questions at that point? Just in case of a question, you can also just raise your hand or just type in the chat box. So I believe so far, so good, right? Okay. The next thing about DS is the types of questions. You normally have two types of questions in the data sufficiency. The first section we'll be looking at is a yes/no kind of questions. These yes/no kind of questions, these are questions which it's consistently yes or consistently no. By consistently, I mean is actually, if a number is actually meeting a condition, it can actually have multiple values, but whichever value you have, it's either a yes or it's a no. If it gives you a consistently yes or a consistently no, then that is a sufficient statement. But if it gives you both yes and no on different circumstances, then it's not sufficient. So that is normally it is. So look at an example, two examples for this. So actually, if x is an integer, is x greater than 0? So first of all, to know in our in our approach of breaking down these are the question stem, which is this one. Don't even look at the multiple choices part, the statements first. First of all, analyze the statement. If x is an integer, so x isn't a fraction and it's not a decimal point. So it's an integer. Integers can be positive or negative. It can be positive or negative, yeah. So you're being asked if x is greater than 0, which means it's x positive. So is x 1, 2, 3, all the way to infinity? So that's the question you're being asked. So what would be actually help us get sufficiency is if you get values that only suffice in this range, they don't have any negative values in their solutions, then we can be able to have this as the answer as a sufficiency. See, that will be it. Otherwise, it won't be sufficient. So in this example, let's see, if x is an integer, is x greater than 0? So we've seen that as our statements and then as our analysis and breaking down, now understand. So we know what you're looking for. So what are we looking at next? The first statement says that x squared is greater than 5. So x squared greater than 5. So since x squared is greater than 5 and x is an integer, we're looking at what values? So we're not looking at 2, we're not looking at 4 because 4 is the smallest number, which is actually squared is actually what do you call it? 0. So you have 4, which you want to look at, but next you have 9, then you have 16, then you have 25, 36, so on and so forth. 49, 64, 81, and then 121, and so on, 44, so on and so forth, all those values. So the question becomes, if x is an integer, if actually x is telling us that x squared is greater than 5. So if this is it, then x can be 9, 16, 25, 36. Then is this x? What is the value of x? To get x, x will be equal to root of x squared, which will be equal to root of, let's say, 9 or root of 16. What would be the values to this? Someone can type in the chat box. The root of 9. You can type in the chat box.
3.
3. Anybody else? Somebody saying 3 and negative 3. The root of 4. Or 4 is 2, yeah, true. Oh, I meant 16. Root of 16, sorry. Should also be 4 and negative 4. So you're considering all possibilities, you see? If you don't consider all possibilities, you will say that 1 is sufficient. But the fact that you have it falling on both sides, you can have x to be either positive or negative because you only have x squared. Then what do you have? That means that it's not sufficient. You see, because x can either be positive or negative. It's insufficient. So let's look at the next one. X cubed. less than 1. So the rules of squares now come into play. So if you miss out on the rules of actually the exponents, you find that you will probably fall into the trap and get this question wrong. See, so we see that x cubed is less than 1. What does this tell us from actually this from the way it is? What will we deduce from this? So which means x cubed less than -1. So x cubed, let's take the cubes. What cubes you have? Let's see. If you have, let's say, 1 cubed, then 2 cubed, 3 cubed, and 4 cubed. 1 cubed is 1, 2 cubed is 8. What did I do? Oh, I went to the chat. Yeah. 1 cubed is 1. It's exiting. God, I don't know why. Why is it misbehaving? It's because I'm going too far up. Okay, 1 cubed is 1. And yeah, 2 cubed is 8. 3 cubed is 27. Let's leave it at that. So if it's negative as well, what will make this to be negative? What will make this cube to be negative is if x itself is negative, like let's say -2 is equal to -2 times -2 times -2. -2 times -2 is 4. 4 times -2 is -8. Yeah. So no matter which value we're looking at, if at all x cubed is less than 1, then unless now you're looking at 0 and -1, -2, so on and so forth. Another question now comes is, we're seeing this 0 here. Is 0 an integer? Because you have x cubed less than 1. Is 0 an integer? It's not. So 0 is not in this range. Yeah, 0 isn't an integer. So with this said, we see that this on itself is sufficient. Yeah, this on itself is sufficient. So for this reason, then that makes the answer choice to be B as in boy. Then you have B as in boy, which says that the second statement in itself is sufficient. The first statement is not sufficient. Right. So because we've got that, we have that, we don't need to proceed to answer choice C, D, E, or E. No, we don't need to do that. We just stop at that. Yeah. Okay. Let's not try. Okay. Yes, Angela. So you have a question.
Yeah. Pardon on the first statement of x squared is greater than 5. Why is it not sufficient?
Because what will be the root of x squared?
It can be a positive or negative.
Yeah. And what are we looking at? Yes, no. It has to be consistently yes or consistently no. It can't be both yes and no.
Okay.
If it gives you this, then that's not sufficient.
Okay.
Right? Makes sense?
Yeah, it does.
Okay. Who's next? Jen?
My question is, why are we saying that statement 2 is sufficient, yet we can have more than one value?
Because it's consistently no. No matter what value you have, whether it is -5, -7, -2, its cube will always be less than 1. Therefore, is x greater than 0? No, it's not. No matter what value of x. We don't have either yes, in some situation whether it is yes, in some instances it is a no. No, it's both sides, it's a no.
Okay.
Yeah. All right. To be more clear in the next example. Now, let's look at the next example. If x is an integer, same question, but different statement. Is x greater than 0? These are yes, no questions. So, first of all, you say, okay, yes, no. So you need to have it consistently yes or consistently no. So 1, x minus 5 is less than 2. Yeah, x minus 5 is less than 2. So you have, what does mean? X minus 5 is less than 2. This means that x is less than 7, right? If x is less than 7, what are the values which satisfy this condition? You can have 6, since they're integers, 5, 4, 3, 2, 1, 0. And then also you have -1, -2, all the way to negative infinity. So you have both positive and negative values on both sides. So for this one, it gives you both yes and no. Is x greater than 0? In some instances, yes, some instances, no. So this is not sufficient. Are you seeing that? Second statement, x plus 2 greater than 2. So x plus 2 greater than 2. So x is greater than 0. This in itself just gives you what the question's term is. If it gives you exactly that, then you don't even need to think beyond that. Just stop at that. They've given you the answer in your face. Right? So this in itself is sufficient because x is greater than 0, so it's a yes. I see. And therefore, the answer becomes what? B as well. The second statement is sufficient, but the first statement is not sufficient. Is it clear now? Any questions on this? Now, the second type of questions which we'll be looking at are, what is the value? This is what is the value kind of question. These are questions which need to have exactly one value. You can't have multiple values. The answer can't be two numbers. It has to be one single value digit. Yeah. So if actually you find a situation where you're finding more than one value, then it's not sufficient. Right? That's not what it should be. So in this case, let's take a look at this example. In the number 3.2xy6, if x and y each represent single digits in the decimal above, what digit does x represent? So we're looking at, let's say these numbers 3.2, then we have some two boxes there, then 6, this is x, y, and 6. We need asked about this number here. What would this number be? See, before we move even to the choices, we need to know. For us to know this value, we need to know either actually, if actually it is to be truncated or actually if anything is to happen, it should only have one. Just any condition you should make it not have one, or not make it sufficient. One I mean is one value. Yeah. So 3.2xy6. So what would this be? As it is, it's hard to think of anything else apart from just going into the statement. So you can't really break it down beyond that. But what we're looking out for is what will affect, how will this position value digit behave in its decimal notation? So the first statement, what does it say? It says that when the decimal is rounded to the nearest tenth, 3.2 is the result. What does this tell us? This tells us that the number in itself is 3.2, and then this digit, x, so x here is less than 5. Given the rounding off rules, if a number is less than 5, it rounds off to the lower. But if it's 5 and above, it rounds up to the next integer. So it doesn't. So that is what but these are the rules. So given this situation, this means that x less than 5. So which means that x is what? 4, 3, 2, 1, and 0. That's a possibility. Because you have multiple values here, it's 4, 3. It can be 4, 3, 2, or 1, or 0. Then this one in itself is not sufficient. Right? Next, let's see. When the decimal is only to the nearest 100th, 3.24 is the result. 3.24. So you have 3.24, and then now y, 6. So the nearest 100th. So what will make this value change? How will this value behave given the various values of y? Because we don't know what y is. Y can take 10 possible values from 0 to 9. So if x is less than 5, is actually, let's say it's 3. Let me see. If x is equal to 3 and y is greater than 4, then x becomes 5. The x becomes 4. Becomes actually the 4 that you're seeing there, right? This will change to 4. But if x is 4 and y is less than 5, then x will remain as 4. So we're seeing there are two possible values of x here. It can be 3 or it can be 4. So unless we know what y is, we won't be able to know what it is. For this reason, this one also is not sufficient. What if we combine them? Now that you have an idea of actually what you need to make the statement sufficient, and actually how these numbers behave, we're seeing that, what do you call it? X in itself is less than 5, as you had seen the first statement above here. And also the second statement is still seeing that it's less than 5, but we need to know the value of y. None of them gives the value of y. If you know the value of y, then actually you can be able to solve for that. But since you don't know the value of y, even combining these statements together still doesn't make this statement sufficient. And the correct answer would be E. Neither of the statements are sufficient together independently. So you still need more information to be able to determine sufficiency, which is the value of y. Is that clear? Makes sense? So are you saying this how the two types of questions will behave? So for any DS kind of question you get, you'll have to first of all determine, is it a yes, no question? Is it a value? What is the value question? If once you know those two, you'll know what kind of answers you're looking for. Looking for either consistent or just a single value. See, and you'll see more of them in your practice. Now, the next thing, you need to know the toolkits required for this. The conceptual understanding is one of the key things you need to know. Know the concepts, all the concepts and the rules on the topic being tested. Secondly, also, algebra becomes a very powerful tool in the data sufficiency. So if you don't know what algebra is, then you will probably have some trouble. If you actually have a challenge with algebraic formulations or algebraic equations, then you'll have a problem with these kinds of questions. So you need to also have that addressed. Here's an example which puts that to test. Like now that you guys know how to go about these ones, let me give you guys like about a minute. You try this question, and then you post the answers in the chat box. Yeah. We give you guys probably a minute. I think 2 minutes are up. We're seeing B as in boy and D as in dog. Which is which? Anybody else? Okay. Now let's see. Is ST equal to T? Now, what would make ST be equal to T? If there were numbers, okay, only numbers in this case, because if ST is ST equal to T. Now let's see. For ST to be equal to T, then either S and S has to be equal to let's say 1, S and T itself, or 0. S has to be equal to 1, and then T can be equal to either 1 or 0. Either of those two. Because then and only then will you be able to have ST being equal to T. Because if S is equal to 1, and 1 times 1 is equal to 1, then yes, that's the case. And if S is equal to 1 and T equals to 0, then 1 times 0 equals to 0, and then T will also be equal to 0. Is that visible? So once you know this one, then actually you need to see if for the conditions, we need to find that only S is equal to 1 and T is equal to either 1 or 0. If you're able to get that, then okay, you have the sufficient statement. Yeah. You get. So that's it. And I'll skip the step of actually asking if these are yes, no question, or what's the value. So is ST equal to T? Yes or no? So it's a yes, no question. So have that in mind. Let's go to the first statement. ST is equal to S is equal to ST. If S is equal to ST, then that means that S is either equal to ST. That means that S is either equal to 0 or 1, and T is equal to 1 only. Yeah, or even 0, but it can't be in both. So if S is equal to 0, only S has that condition of being equal to 0, then 0 will be equal to 0 times 1, which is equal to 0. But in this case, it's saying S can actually have either of those. So since S is not meeting the condition in the first statement, as it is in the question stem, then it's not sufficient. Not sufficient. See. Because S has to be equal to another value. And 1 in this case can also be represent another value. It can also be 2, 3, 4, 5, or something. Yeah. So S has to be only one given value. It has to be only 1. It can't be equal to 0. This in itself not sufficient. And then the second statement, T is equal to TS. And one trick also in data sufficiency is, as we had seen in the previous example, was it this one or which one? It wasn't this one. Which one was it? There's an example I think I looked at where one was just the form of the second one. Oh yeah, X is greater than 0. This example here, where we're seeing a statement being just a form of the question stem, then that's sufficient. If you look at this statement as well, T is equal to TS is also similar to T is equal to ST is also equal to, which can be also written as the same form as the question stem. So you don't even need to go further to solve this, to save on time. This in itself will be sufficient. And the answer would be B. Nonetheless, if you have to go the long way still, you'll still see that for T to be equal to TS, yeah, for T to be equal to TS, then actually do what? Only T, okay, T can be either 1 or 0, and S has to be 1. Yeah. Sarah.
I'm okay with your answer, but I have a problem with something you said first. The first statement you wrote up here. You said that X or S is equals to 1. What about this T is either 1 or 0?
That's because if S is equal to 1, then T also has to be equal to 1 for it to be the same value as T. Because 1 times 1 is 1. right?
Okay, that's okay. But then
if t is equal to 0, if t equals to 0, then 1 times 0 equals to 0, which will be equal to 0.
So
in the first statement, we're seeing that in that case, so look at it this way. Which one can take, if you look at the question stem, we're seeing that the value on the opposite side of the equal sign is the one which can take 0 or 1. Are you seeing that?
I'm losing you.
Are you seeing that? This value on the other side of the equal sign, which is t in this case, it's the one which can take 0 or 1. The one which is actually as part of this other value, it can only be one value, or also 0 as well, but they can't be both 0 at the same time, or actually, for it to be really sufficient, it can't be overlapping both ways. You get me?
Okay, but now statement 1 means that t is 1. So if you look at it, t is 1. So that is why I got confused. I thought the answer is B also at first, but now see t is 1. Also, if t is 1, s has to be 1 for s to be 1.
Yes.
Oh, okay. Wow.
Yes.
Thank you.
Very good. Anybody else? And you're seeing how the algebraic logic is confusing in this short, simple statement. Unless you know algebra well, oh, Kuramba. Anybody else have a question on this? So
Hi.
always look. Hi.
Yes, I have not a question, but I worked out differently, but I landed on the same answer.
Yeah.
My thinking was, if
Yes.
st is equals to t, what if you say multiply odd and even, you get even?
Huh?
So statement 1,
which is still 1 and 0. Are you seeing that?
Yes.
So still it will work because just a different version of the other one. Yes, that still works. So statement 1 means. Go ahead.
Yeah, it's
Statement
okay.
1.
It's just the same thing. It's the same
It's the
thing.
same. But actually, I think yours could be more clearer because it depends on how somebody wants to view it, but still, it makes more clear sense. And the essence is that how are you formulating your algebraic expression? So if actually you have odd times even equals to even, then which one is the odd in this case? Which one is the even? That's the question which you want to pose. You see, is S the odd one? Is T the even one? Are you getting me? So if you're going that route, then T will have to be the even one, and then S will be the odd one. So we're having here in this case, since statement 1, actually it could help to simplify that. We have it even is equal to even times odd. This is not true. Not true. So not sufficient. And then 2, we have even, this is actually what? This which is which? And I'm confusing these ones. I think
We have
I'm supposed to be the other way
interchanged.
around. Or they change them. This is statement 2 now, right?
Yes, that is statement 2.
Yeah, which is true. So this is sufficient. And now in the first statement, now we have as odd is equal to even times odd. Yeah, which is not true. This is the approach you used?
That's what I used.
Yeah. Yeah. It's also quick and also saves on the time because that's it. So for another shortcut is normally be on the lookout for which statement is actually giving you exactly what you're being told in the question stem. That one is sufficient, definitely. Don't even spend time working on it. Don't even waste a minute. ST is equal to T is also equal to T is equal to TS. So don't even spend time. And that way you'll save yourself some time.
You're watching Success with Bob Mwiti Show, presented to you by Upstack America. Upstack America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstackamerica.com. Upstack America, we wake you up to the unlimited potential.
Okay, the next thing you need to have in your armory, you need to be suspicious. Try to find out why a statement that looks unimportant exists in the question. You'll see some of these, especially when you get to more difficult questions. You'll be seeing some statements which they don't seem important at all, yet they are there. These guys are not stupid to put it there. They are cunning to put it there. And they want to trick you into thinking that this is a useless thing, so it's not sufficient, so leave it out. Yeah, that is one thing. Be suspicious. Whenever something that is not making sense or doesn't seem to be like important and it's there, hey, be very wary. Ask yourself why it's there. Okay, the next thing is leverage on your assets. The assets is the information being told, like what I was doing earlier, I was just leveraging on the asset, like referring to the question stem to see if it's the same. That's an asset. The question stem and simplifying it is an asset. So leverage on that to save on time. So the next thing also, use each statement to inform on the aspects you might have missed on a different statement. So you may sometimes actually go through something, a statement, and even run it as sufficient or not sufficient. And then you see the next statement, it gives something that tells you, hey, wait, this, I didn't look at this aspect in the previous statement. What if, then you find that maybe changing your perspective on that. See. So also be alert and be on the lookout for that. So here's an example which I'll also give you guys to try. Try it out. Then I give you guys 2 minutes to tell us which is the correct answer. Julie opened a lemonade stand and sold lemonade in 2 different sizes. 2 cents or 12 ounces glass or cup, and 58 cents for 16 ounces cup. So this is basically 300 ml and 500 ml sizes. How many 2-cent lemonade drinks did Julie sell? The first statement, he sold 9 lemonades. Second statement, total value of lemonade drinks sold was $4.92. So give this a shot. So we have multiple answers here. You have B's and you have E's. You have B's and you have E's. B's and E's. Okay. So how are you guys going about this problem? I'd like to ask either Sarah or Zipporah to walk us through the approach that they've used in solving this. Sarah?
I can try, but actually I had seen this question somewhere, so
don't try, just leave. Zipporah? Zipporah, have you seen this question before?
Yes, I have seen it before. I can,
All right.
though I can explain my approach anyway.
Okay, no problem. I don't want to ask somebody who's seen the question before.
Okay.
How about Margaret? Margaret?
Oh, hi. I've seen the question before. We did in the last class.
Seen it before. And Yvonne?
Yeah, I've seen it before.
So everybody who's gotten this question right has seen it before. That's actually one thing I wanted to prove, because many times E normally actually is the answer that people tend to get, but the correct answer is B. Let's see how we get there. So, for this information, what do we have? We do know that there are two sizes. Let's call them X and Y, and they both fetch different prices, and they are sold. So they have, let's say, the 52 ounce or the 12 ounce. Let's call it X. So we have 0.52X. Then also we have 0.588Y. And then we're being asked of how many X's do we have? So we need to find how many X. So X has to be a single value. These are what is the value of. Yeah. How many X's does Julie sell? So these are naturally, we do have this. So this, since she's selling, the amount sold will be equal to the number of each size times the price. Then we add them together, we'll get that. So for if actually we're able to get something which helps us get close to that, then we'll have an answer. So that's what this is. But from what it stands, it's a bit difficult to demystify it further. But just know that this is algebraic question you're addressing. So it's more of a word problem kind of thing that you're trying to solve, and actually don't have some information. So that's what is coming out. But we need like a specific value. X has to be one value. It can't be two values. So the first statement says that Julie sold 9 lemonades. So first statement says that she sold 9 lemonades. So that means that X plus Y is equal to 9. How many values can X or how many combinations of X and Y can we have that give us 9? See. So let's have on this extreme end X and then Y, this side. So we can't have it as 9, 0. That's not possible because she sold both. So the most it can be is 8, 1, then 7 and 2, then 6 and 3, 5 and 4. Then also you can have it vice versa, 4 and 5, so on and so forth. And then 3 and 6, till we reach the very end. That's a thing we can leave at that, but you get the logic. So for this one, it means X can take any value. X can be anywhere from 8 all the way to 1. So we have more than one value of X. So this is not sufficient. Are we together? I believe there could be no questions. Now the next thing is the total value of lemonade drinks Julie sold was 492. So 0.52X plus 0.58Y is equal to 4.92. If we simplify this, we can remove the decimal points because multiply all through by 100, then divide by 2. What will we have? We'll have 26X plus 27, this is 29, right? 29Y is equal to 2, and then I'll have it as what? 2, then 4, 6. Yeah, 246. So this is it. So the question is this. We have 26X plus 29Y is equal to 246. And there is normally this thing in algebra. Remember actually talking about algebra being part of your arsenal and knowing it well. Could there be possibility that there are only two values, which when plugged in here, they give us 246, and there is no other combination? Before we rule this one out, that's not sufficient because yes, you could have multiple. So if there is only one combination of X and Y multiplied by 26 and 29, give us 246, then that is, then we have an answer. But if there is none, then it's not sufficient. You see. Now, here's the thing. And here's where it normally gets a bit confusing. For us to think of this, what would it be? If, let's say, we multiply by 10, let's say, just by thinking out loud or estimating, if actually multiply by 10, we have 26 times 10 will be 260. That's greater than 246, so it can't be 10. Neither can it be 10 or 29 times 10 also can give us 290 greater than 10, so that can't be it. So we start looking for numbers that could be lower, that could help us get to that. Let's see. And let's say this 10, so maybe now if you go to 9, that would mean this would be 0. We can't have 9, so it has to be 8. And actually, from this one now, you see, we ask ourselves, why were we told about these 9 lemonades, which are sold here? It's unimportant, it's insufficient, and yet it's there. Can't you see? Don't you see it's like a hint they're giving us? It looks like they're giving us a hint that maybe what they sold were less than 10. As you can see here in this equation, B. And actually, maybe they're all just 9 lemonades sold. Or maybe they're two combinations of numbers, which when you multiply here, they'll give you 246. So then again, that comes, do we have to go try out all these numbers and see? One trick I do normally have is, you see the knowledge of concepts, having them in your head, number properties. If you look at these digits, we have an even number and odd and an even number. You see? If actually for even plus even will give you an even, odd plus odd will give you an odd, even times even will give you an even times, and then odd times even will give you an even. So since we're adding two numbers to get an even number, it means that both of them are either odd or even. Since 26 is even, regardless of what x is, it will end up being even. Since 29 is odd, y has to be even. Right? Y has to be even. If y has to be even, if y actually has to be even, then x will be odd. No, not really odd per se, but yeah, odd because you're looking at 9. That's it. So from this list, you're looking at which numbers, y being even, you're looking at either of that, or this, or that, or anything there. So let's see. So now you can try out these, instead of sifting through all of them, let's try these ones. For the guys who found E, can you try these ones and tell me if there's any one of them? 29 times 2 will be 58, right? 58 minus 246. That's 58. 16 minus 8 is 8. 13 minus 5 is 8. Then 188. 26 times what? This 7. 26 times 7. 6 times 7 is 2, not 8. So that's out. So got the next one, 4. 29 times 4 will end up with a 6. I just read the last digit. Let's just try the last digit. With 36. Yeah. And then 6 times 5 will be 0. And this last digit is also a 6. So it looks like you have something here that if you add them, getting 246. So 246. So, okay, so 29 times 4, 9 times 4 is what, 36, 3. 2 times 4 is 8 plus 3 is 11, right? 11. And then 6 times 5, 26 times 5, 25 times 5 is 225, is 25 times 5, 125 plus 150. Is it 150 or is it 136 or what? 26 times 4 times 5. I think I'm messing up with my math, with my calculation. My head isn't thinking so straight right now. But it looks like it's 5 and 4, me, without even thinking further, because it's a sufficiency kind of thing. 6 times 5 is 30. 33, 2 times 5 is 10, 130. Yeah, it's 130, not 150. Then yeah, if you add them, you get to 46. That's it. So it's this. So with that one, the answer ends up being B. These have become sufficient now. So this is sufficient. But take note, we have not used statement 1 in solving for this. We've used as a hint, not as combining. I'm expecting questions. Yes, Angela.
At first, I never understood why you rolled out statement 1 not being sufficient. Why is that so?
Because you tried all the combinations. How many combinations of X and Y can you have that add up to 9? Because you have X plus Y equals to 9. Julie sold 9 lemonades, right?
Mm-hmm.
So which means the different sizes of X and Y, right?
Mm-hmm.
How many numbers can you add together to give you a 9?
A lot.
Yeah, so we have more than one. Yet our question is asking us for what is the value. You need only to have one answer, not two.
Okay.
So you can put your hand down. Someone else's hand is up. Is it Sarah? Or Nani?
It's me. When I first saw this question, I thought the answer was C, both of them combined. Because now see, the first one is like the first equation, then the second one gives you another equation, so you can solve them and easily get the values. So now, in future, how should I so for such questions, is this the approach? Like, is this the structure? So I don't jump fast to get the two equations and solve them. Is it always like this for such questions?
Some, yeah, the tricky ones, especially, well, no, you can't know which difficulty you're dealing with because you'll be an exam and what you care about is actually getting the answer. So first of all, just think, don't miss out on anything. Don't miss out on anything. Where was it? Consider the possibilities.
Okay, so there can't be like a structure I should have in my mind, like a system I can always use for such questions.
What you can have is, in algebra, know actually the types of equations we do have. All of them, just know all of them. Especially those tests in the GMAT. This one falls in the group called Diophantine equations. You can go read more about it. Equations. Go read more about it. Diophantine equations, these are equations which only have one solution. They have two unknowns, but only have one solution.
Okay, thank you.
So, that's Diophantine for you. They have two equations, but only have one solution.
So,
yeah, for instance, let's say x squared plus y squared is equal to 116. What is the value of x plus y? Are you saying that?
See, for this one, I'd first factorize x plus y, x minus y is equals to 116.
Something like that, but what this means is that these are two squares being added to form 116.
Yes.
Which two squares are there which when they're added, and if you factorize this, it only works if you're multiplying, because factorizing normally works with multiplication, not addition.
Okay, so I don't need to factorize like for this one. I just need to think about.
You don't. Okay. Just treat them independently. X squared plus y squared equals to 116. So this actually is the sum of two squares. So if I to sum two squares, let's say 49 times 149, that's 98. So that's less still. Let's start with from the largest, maybe bigger than 116. Which two numbers squared? If actually they're together, you get them. 8 plus 8. No, 64 plus 64, that's more than that.
It's 10 and 4.
Yeah, you see. And that's the only solution you'll have. You get?
Yes.
So these are the Diophantine equation.
Okay, do I really need to read deeper? Because
it's not complex. It's just okay. What you should do is just understand it. Period. You don't need to like have it as so much, and you won't see many of these questions. I normally just have this one here is simply because it's normally not showing up a lot, but it's still very vital. And it also helps in actually probably demonstrating this aspect of giving us the hint. That is the main thing that we're looking at. How do we find a question which you can use some information or previous what do you call it in a different statement to address our problem. You see, that's the main aim of this. Yeah. It's not about making things complex. No, that's not the goal.
Okay, I think that helps. Thank you.
Karibu. Yes, Felista.
So for this type of equations, is there like a criteria you can just look at the equation at a glance and you can know it's this type, like it has only one pair of x and y?
Many times there'll be small value numbers. There won't be big ones. Like this one is saying the x plus y is equals to 116. Just 10 and 4. You see, they won't give you like 3055. Let me see what. No. They'll give you numbers which you can easily break down and get. You see, like this one, like in this case, we didn't have to like sift through all the questions to narrow down. We just had to use like the knowledge you have on number properties to help us narrow down on which numbers to work with. And in about two steps, you were able to get our answer. You get?
Yeah.
The even plus odd plus even. That's why I normally say that it's very important to know those concepts and actually have them and then try and see how do they behave. Try and look out for them because you normally see a pattern. The last value of a digit, you'll always see the last value of an operation or something, you'll see them. So you won't really get like big numbers. No, they'll be simple. They'll be small numbers. And okay, really? Did they have to do this? Why are they doing this to me? You see?
Yeah.
Yeah.
So just by looking at the constances, the coefficient of x and y, you can't tell. You have to try out the possibilities. But
You
just
try
by
them out and estimate.
Okay.
Yeah. Like you see here in estimation, we started off by using, let's say, 10.
Yeah.
10 to give us like, okay, so it has to be less than 10 because 10 times 26 is 260, greater than this. So it can't be 10. The same time also it can't be 9 because 9, given the hint, we were told that it sold 9 lemonades. It sold both of them, so it can't be 9. One has to be there as well.
Yeah.
You see, so that one now you see, okay, maybe it's an 8. Then now you see, okay, wait first, before digging down further, what else can we miss from this? We're adding two numbers. Is it odd? Is it even? Is it a prime number? Is it what? So on and so forth. And the more you do practice now, they'll start showing up. They'll just start appearing to you.
Okay.
You'll start seeing them more and more patterns show up.
Okay, thank you.
Very well. Anybody else? Okay. Something else you need to know. Those toolkits and the things you've learned, that's something else you need to have. And then the normally traps which they have, like the ones you've seen before. You think a statement is sufficient when actually it's not sufficient. And sometimes also think a statement is not sufficient when actually it is sufficient, like the second statement in that previous question. Yeah. And the third trap is one statement is a form of the other. You remember actually I'm talking about one statement being the form of the question stem as a trick. Now you have another situation they'll use is one statement is a form of the other statement. That's another trap you need to look out for. So be on the lookout for these and those kind of traps are things which normally when you capture them, I'd be pretty much in a position to address to get these questions correct. So let's look at one example. Then I believe this could probably one example, and the rest are just practice questions for you guys to look at. So yeah, let's look at this one more example, then you can see if you can still proceed or not. All right, your teammate starts now. Try this question and then let's see. What's the value of x? The value of x, it has to be one value. It's only x we're being asked about, right? So we look at the statements, the algebraic expressions. So algebra, all your algebra arsenal, have them ready. All of them have them ready. So since you don't know actually anything, we can't simplify the questions time, we just need to dive into the statements right away. As long as it gives us the value of x, that is sufficient. If it can't help us get the value of x, it's not sufficient, right? So here we are, 6x plus 4y equals to 30. So that's simple one. So if you simplify that one, it will simplify to what? Divide by all through by 2, we'll have 3x plus 2y is equal to 15. Now, is this a defined equation? It's not, is it? A defined equation? That's the first thing we need to ask ourselves. Because you have two unknowns and one answer. That's for differential equations. If you have two unknowns and you have one of them that, okay, we have actually two values that can satisfy that condition, then it's good. So what numbers, if you add together, gives us 15? We have 10 and 5, and each of them multiples of these. Now, so nonetheless, if you also go by the coefficients of x and y, 3 and y, x plus, which is odd and even, give us odd, then that means that x has to be odd and but y can be either odd or even. So x has to be odd. That's what you're seeing. See? Because you're actually adding up to get an odd number. So it has to be even and odd to get that. Because 2, you already have 2, yes, it's going to be even. So x has to be odd. So two odd numbers you add to get, numbers you add to get 15, 8 and 7, 8 and 7, you get 15. So let's say 15, you have 15 there. 15, 14 and 1, 2, but you have 2, so 2 times, so that means the smallest number can be 2, so it can be 13, so 12 plus 2, 3, no, it has to be, are we told of anything else? No, it's not. Trying to see if at all there's actually 8, this is x and y, so this has to be 7, 7 and 8. That's something we have. That's we have 10 and 15, so 15, 5, 10. 5 and 10. The numbers do you have? 14, 1 can be, so 13, 13, 2, and so on and so forth. So we have several things. So at the same time, we're not getting any value which you can add to this. And we haven't been told if this is an integer or not. So at the same time, even going through all this hard work we're trying to do here may not be necessary, because if it is not an integer, then it's a fraction. We can have multiple possibilities. We can have multiple possibilities. Yes, Jen has it. 9 and 6, right? So that now x becomes now 3, and then y becomes what? 3 as well. That will give us 15. So the question is, consider all possibilities. If it were integers, and these are defined in the equation, then yes, we'll have an answer. But can it be decimal or a fraction? Yes. Because we haven't been told that x is not a fraction, or actually this is a decimal not, it's open. If it's open, I believe you can get so many fractions to satisfy this condition. Therefore, you won't have one value, you'll have multiple values. So this is not sufficient. So otherwise, ingekuwa a. If actually it was like this an integer, asingejitokeza haraka sana. Next, second statement, let's look at this. Let's simplify this to what? Let's say remove the fraction. So we'll have negative 3x is equal to 2y minus 15. This looks like our first equation. Let's see. Can you write it to have it all through, let's say, what? Let's multiply through by negative 1, 3x is equal to negative 2y plus 15. Take 2y to the side. 3x plus 2y is equal to 15. This is the same as this. Therefore, if this is not sufficient, this also is not sufficient. So even if you combine them, you want to get sufficiency. So even if you combine them, so the answer will be E. Any questions? Any questions on this? Yes, the answer is A, Charles. This seems to be clear, right? Okay. Let's try another one. Just one more, then now I can call it a session. Or probably some few more if you guys want. Let me see, what time is it? We still have some time. Still try some more. Let's try this one too. Okay, so anybody hasn't seen this question before and has done it? Anyone? So you've all seen this question before? Okay. So what's the ratio of the average height of students in a class, the average height of students in a class Y, or class X versus class Y? The ratio of the average height of students in class X, the ratio, the average height of students class Y. So you have average X, average Y. Either that or you can put the column depending on which way you want to express this expression. So you need to know the average of X, the average of Y, know that. At the same time also to get these ratios or proportions, for the ratio is going to be literally the total. So total of X. So X times what? Trying to put a number here. X being the mean times N1, yes, let's call it N1. Then plus X Y times N2. This number of, that's the whole weight we'll have. And then now X times N1 divided by that, then to X times N2 divided by that. So what am I trying to say? This for the proportion part, where you have actually 3 to 4. If actually can get to not a number of weights, this will be 7. Yeah, so 3 out of 7 and 4 out of 7. That's what I'm trying to get in all this. Yeah, or even though you can just still have it as 3 over 4. I still have it as that as a ratio. But the main thing we're looking at to get the ratio is to have this form of expression, to be able to have all that. So you'll have X over NY over X times N1 over all this, then the other one as well. So you're looking at X times N1 all over here total. And then again, Y times N2 over total. So which is this total. Total over there. So with that said, now we can probably go ahead and look at the statements. This is how you come up with the ratios. So if you get this one, average of this, then actually the average of that, X and that, N1 divided by N. Yeah, so anyway, you get the logic. Yeah, that's the main thing. So what will we have? Well, between 3 and 4. I'm just giving an example, Winnie. Just giving an example. Right? So the average height of students in class X is 220. So how many students are there? We don't know. Because if you know the students who are there, then you can tell. Or, okay, the average students in class X, okay, it's average height is on 20 in X. How about the average height in class Y? We don't know. We need these two as well to be able to get that height. So that's one thing I need to know. So in this case, it's not sufficient because we don't know how many students are in Y or the average height. The average height of students in class X and Y combined is 126. So average height. So if we add all these, total number of them, all of them divided by X, in fact, so you have X times N1 plus Y times N2 divided by N1 plus N2 is equal to what? 126. So does this tell us how many we have for either of them? Be able to know? No, we don't. It doesn't tell us how many the average height in X, neither does it tell us the average height in Y. It doesn't really tell us much. If you don't know about these two basic fundamentals, we can't get that. This also, it's not sufficient. Or is it? So the next thing is combining them. If you combine them, what do you have? You have the average height is 126. So average height will be X times N1 divided by N is equal to 126. So average height is 126, then plus that. So if you multiply all that, then we still need to know for, how about for Y? Because we need that as well. Average height students in Y and Y. Can we get that? Given this information, are we able to get the number of the average height of both? Because for us to do that, we need to know what N1 is and what N2 is. We need to know what N1 is and N2 is. If you have this one, then actually can calculate the average height for actually the other one as well, for Y, since it's plus Y. But for X, we have the average, yes, but for Y, we don't have that. So we need to be able to calculate for Y as well. See, if you can be able to do that, then it will be sufficient. But from this information, you don't know, is it possible to get the number of students in actually class Y with this information? If you combine them? Yes, Sarah.
I have a very funny question. I'm
Ask us,
wondering,
then maybe we laugh, then you answer it.
assuming we have the average for class X and the average for class Y, can't we add the 2 and divide by 2 to get the average for the two combined? It's not going to end to the same thing.
Okay, it was a bit funny. There's the simple average, then there's the weighted average. Do you know that?
Yes, I know.
How do those two come about?
Simple is the one you just add and then divide by the number of elements.
Yes, and the
weighted.
And
then the weighted, there's, okay, how do I put it? There's like a proportion to it. There's a weight you.
Where does that weight come from?
Know? Sorry?
Where does that weight come from?
Oh, okay, the total number.
Yes.
Like we can't assume these classes have equal number of students, so they'll contribute equally to the.
That's it.
Okay.
That's the trick to average questions. Whenever you see average, be very wary of the total number of elements. How is it? If you don't know that, then you may not be able to solve for this question. I think I'd seen a hand up. Was it who? Irene or? Is anybody else with a question on this? Okay, so Sarah Mona, you've seen actually why it's not really possible to do it just like that.
Yes, that's okay. That's okay.
Yeah. And the same also applied to speed, distance, and time. That also normally comes into play a lot. At the same time, also it comes to play with the work rates and time. Anything that has rates in it or just have like proportions of things being done there, be very careful before you just assume. So the answer will be E. Unless you know the number of students in both of them, you can't just assume. So it's going to be E. Even if you combine, we need to know the number of students. This N1 plus N2 is very important. So, I think I'd like to stop the recording at that point.